Hi everyone, and I'm happy to be here with you for this webinar around Airbyte Serverless and deploying 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 a serverless data platform to GCP with the tools like Airbyte Serverless, Google Cloud Run Job, and Workflow. So I'm going to firstly introduce you the table of content. So today we're going to discuss many things. Firstly, present ourselves, present the hosts. Then we're going to introduce what is a modern data platform and the comparison between the legacy data platforms. After that, I will let the stage to Lynn on the Paul to introduce us about Airbyte Serverless. And we'll finish this webinar by a demo for a use case that we had with our customer. So, Paul, you can start to present yourself if you want.
Cool. Maybe you can go next slide.
Yes.
Yeah. Okay, cool. So, hi everyone, I'm Paul. I'm head of data at Nickel. Nickel is fintech. We open current accounts. Here are some figures of what we do, and if you need to just remember one thing, what we try to do at Nickel in the central data team is to empower people, empower business teams to have impact with data, so that empower people so that they can do everything about data, from collection to deployment of algorithms. Yeah. We can go to the next slide. So I wanted to go even further than empowering data analysts to deploy algorithms or so on. So that's why I developed and created 1 year ago an open source product which is called BigFunctions, which provides some ready-to-use BigQuery functions. And it's also frameworks enabling you to create your own catalog of functions, of BigQuery functions on top of inside your company. So today we are going to talk about another open source project that I created, which is called Airbyte Serverless. Yeah.
Okay. Thank you, Paul. And I'm going to introduce myself because I didn't tell you, but I'm the co-founder and CTO of Modeo. So Modeo is the consulting tech company in Paris. So why did we create Modeo? So Modeo is a young consulting company, and we focus our values around three main components: innovation, because we founded it. I founded it with my friend Matthew, and both of us like technologies, innovative tools, and we found that being working in data in data is the best way to build innovative product and to bring values to people. That's why we created Modeo, so centered on innovation. And another thing is the people. So when we build like products, we build data platforms, we want it to be used by people, and also to help people achieve the professional goals. And the last thing is the Airbyte. So we are a Airbyte centric company. That means when we build products, we build data platforms, we not only want to build uh, like uh, fancy products or fancy data tools, but we really attach a precious attention to the way the product will be used, the way the data will serve people in the daily activities, for example. So that's the three principle around what we created Modeo. And I will tell you about a few story about the creation of Modeo. So we created it in 2013. Then we joined Station F the same year. and then we moved to our new our office in Paris. Then in December 22, we created our internal product called Stash, which is a tool designed to help people understand the data platform, the activities, the cost, on this project. By the way, won the first prize at La Nuit de la Data contest organized this year. And now we are a team of 20 passionate data engineers, mostly data engineers in Paris. So that's for the small story. This is what we have today. And at Modeo, as I said, we are a consulting company focused around three offers. We principally we build like for the first offer is to help customers build custom data platforms, so it can take months. The second offer could be bringing them a custom a plug and play data platform. So instead of waiting for months before getting insight from data, you just wait a few days. And then the last solution is the product we're building now internally called Stash, a data monitoring tool, which is used by customers to monitor the data activities, the costs, the usage, and even the carbon cost of the data platform. So this is for the small story. So what is a modern data platform? Um, when we speak about data platform, modern data platform, we mostly compare it to legacy data platform. So a simple definition of a data platform is a set of tool and practice in an organization that helps the organization meets the end-to-end data needs. That means it's a set of tools that enables the organization to acquire data, store it, prepare it, and deliver to what we call data consumers. And after that, we'll also add another layers like data governance, data securities, and stuff like that. So, what is the advantages of a modern data platform against the legacy data platform? Because data platform have already always exist, but today the difference is that storage is cheap. We are mostly in the cloud, so we gain speed in implementing the solutions. So by using the modern data tools, first we can have the speed of implementation. So instead of months, even years of development, many big projects can be delivered like in few months. The second point could be the maintainability. So the tools that the modern data stack bring to us is that it's generally it's maintainable. So it's a kind of Lego that works together. So each piece of the tool can be managed independently without breaking another parts of the data platform, for example. The third thing is scalability. Most of the tools are cloud-based, are cloud-first tools. That means they are built in the cloud. Cloud is scalable, infinitely scalable. So you will probably not be limited by the scale of your data. And the last thing is the cost. No, the fourth thing is the cost. So most of the data stacks, the data text components that are used in a modern data platform are integrate natively the cost management, cost monitoring. Since we are working in the cloud, we have like good observability tools to measure the cost, etc., etc. So you will be able to easily monitor the cost of your IT, the cost of your data. And the last thing is agility. Since we all know that in the data space things happens fast, so agility is important. In that means that companies should be able to adopt new technologies faster, to test new methodology, new technology faster, and using the modern data stack tools enables them to do that easily. And at Modeo, we have our selection of tools that we use a lot in for our customers, like for every part of the data platform, like storage. We can use BigQuery, Snowflake. For orchestration, we can use DBT, Airflow, Dagster, Ingestion, Airbyte Serverless, or even Python custom code, Fivetran. And in the activation layer, we have tools like dashboard tools like Power BI. We can also have reverse ETL like a high touch, which is not in the slide, but we can use it too. And the last thing is the governance tools. That are a set of tools which are used to bring some governance around the security, data access, data catalogs, on stuff like that. Now I'll let the stage to Lynn, and she will tell you about Airbytes and Airbyte Serverless.
Hello, everyone. My name is Dean. I'm a data engineer at Modeo. Before we go into details about Airbyte Serverless, it's important to understand what Airbyte is. Um, yes, so Airbyte is an open source data integration platform that helps in the collection, integration, and moving of data from numerous source applications and APIs into data warehouses, data lakes, and other centralized destinations. The basis of the functioning of Airbyte is the building and the maintaining of connections between sources and their destinations. And the goal of Airbyte is to simplify, automate, and streamline the process of ETL or ELT. There are many reasons why Airbyte is so successful, and this shows in the numbers here. There's over 3,000 companies that are currently using Airbyte. Airbyte contains at the moment over 350 connectors, which you can choose from. There are 800 code contributors of Airbyte, and there are over 15,000 people in the Slack Airbyte community that can help you. There are many ways to use Airbyte. The first and most simple or straightforward way is Airbyte Cloud. Airbyte Cloud is a fully managed cloud-based version of the Airbyte platform. In Airbyte Cloud, you can choose from over 200 sources and over 30 destinations to configure your connection in the user interface. The advantage of using Airbyte Cloud is that it's very easy to set up and it's very easy to maintain, especially because you won't be writing any code. You just have to choose your source and your destination and do the configuration in the UI. However, the cloud also has disadvantages, and it's that it's very costly, and the user has very limited control over the infrastructure of the connection since you are doing no code, and you have very limited offline access to the connection as well. Next slide, please. The second way to use Airbyte is through the self-hosted Airbyte. So the self-hosted Airbyte allows users to deploy and manage their own instances of the Airbyte platform. And in this case, users have more control over the infrastructure and can customize the deployment to meet specific requirements. There are three different ways in which you can deploy the self-hosted Airbyte. There's the no-code connector builder, the low-code connector development kit, and the Python connector development kit. So the first no-code connector builder. It's very similar to what you do in Airbyte Cloud. It's just the only difference is that you are running your own instance of Airbyte. You have a user interface, and this method is usually used for when you want to implement very common, very standard, and well-documented APIs or cloud services as your source or destination. The second way, which is the low-code connector development kit, here you are allowed, as a user, you're allowed to do a bit more manipulation. You're still not doing intense coding because it's just the modification of a YAML file, of a YAML configuration file. It allows a bit more flexibility, however, than the no-code connector builder. And finally, you have the Python CDK or Python Connector Development Kit. This is usually used when you want to customize a source, or when you want to use a source or a destination that don't exist already in Airbyte, in the listed Airbyte options. So in this case, it's a fully Python-based development. And in this case, obviously, you have the highest level of flexibility and customization because you are deploying the code, you are performing the logic for extraction as you wish. And so, therefore, you have full control over the connector's behavior. And in the fact that it's Python-based also allows you to create, test, and refine as you go. You can write small pieces of code and test at each step to make sure that everything works good. It's also to understand how Airbyte Serverless works. It's also really important to understand the steps followed for implementing a custom source or simply a source in Airbyte. There are 4 main steps. There's spec, check, discover, and read. In spec, this is where you identify authentication requirements. You determine how the source connector will authenticate and connect to the data source. And this is where you specify what the connector expects in terms of configuration inputs. The second step is the check, and this is where you verify that the configuration of the source connector, or this is where you check whether the provided configuration details are valid and sufficient for establishing a connection with the source. The third step is the discover, and this is where you specify the schema of the data that is to be extracted. It's usually the JSON format of the data that you want to extract. The read step, this is where you actually perform the syncing of the data from the source. This is where you implement the extraction logic. And optionally, you can also perform some data transformations at this step. So this brings us to the main constituents of an Airbyte CDK code, which are based on the 4 steps mentioned before. The 4 main files that are obviously, there are many other files, but these are the main files that allow for the functioning of a good Airbyte code, source code. The first one is the spec.yaml, and this is the configuration file. It structures how you would, which inputs you would like to give to your source connector. It could be credentials, it could be a token, or any sort of input that your source expects. The second file is the configured catalog YAML. This will specify the format of the data that is to be retrieved, the JSON format, and this is also where you define the sync mode. So whether when you obtain the data, you would like to have full refresh or incremental, and when you deploy the data into the source or load the data into the destination, you get to choose if you want to overwrite or append the data. The setup.py, it's standard. This is where you define your dependencies, the Python packages that the connection needs. And finally, the source.py, which is your main Python code. And this is the main Python script that contains the entire logic for connecting the source system, extracting the data, and transforming it as needed. And in this point, you define what in Airbyte we call streams or data sources. And typically, when you're writing an Airbyte CDK code, these files are generated automatically with the standard templates, and all you have to do is fill them out. So there are for the self-hosted Airbyte, there are several pros and cons. The pros is that it's open source. You have the option of customizing your connectors as you wish. And you have almost full control over your data infrastructure if you need to. And the Dockerization of your code allows for the portability and isolation of it as well. However, on the other side, you still do have to do a lot of maintaining for the code. There's a lot of higher chances of having errors in your code because you are the one setting the code up. So there's a lot of maintenance as well. And there are some scalability challenges as well for the self-hosted Airbyte. And obviously, because of the intense coding and testing, it takes a lot of deployment time.
Okay, so let me share my screen. Can you see my screen?
Yeah.
No.
You are?
Yes.
Yes, okay. So thank you, Lynn. And so now we are going to speak about Airbyte Serverless. Airbyte Serverless is a small Python package to handle Airbyte connectors and to host them. So actually, most people will use Airbyte Cloud on the UI directly, and people who want to host Airbyte themselves for some reasons such as cost, they will have two options. The first one is the Airbyte open source platform, which is very nice, which comes with a lot of stuff, but which is kind of difficult or hard to deploy if you are not a Kubernetes expert. And I created a small Python package to handle connectors, which is called Airbyte Serverless, which has a lot less features than Airbyte open source platform. But as you will see, it's very lightweight. So it's the Airbyte Airbyte deployment way in the YAML era because there's no UI. The configuration of the connectors and the connections is made by a YAML file. There's no database. It's more like DBT. You host the YAML files in Git, so it's stored in Git. So you don't need to have a database anymore. And so yes, and it doesn't do the transform stuff that Airbyte is adding, and it is easily deployable on some serverless compute. So now we are going to see how it works in practice to try to show you how simple it is. So first you will install this Python package, which is called Airbyte Serverless. Then it will give you a command line interface like DBT. You've got a command line which is called ABS that you can use to manage your connectors. So first, what we are going to do is to create a connection between a source and a destination. Right here, you've seen that I've chosen an Airbyte source connector, which is Faker, which is one of the easiest to start with. And I chose a destination, which is BigQuery, right? What you can see as well is that there is an option of a remote runner that we are going to speak about. Cloud Run Job is on GCP. It's a compute deployment serverless way of deploying. So when you run this command, I've chosen Airbyte Source Faker as a source, but actually you can choose any source that you can find on Docker Hub. Airbyte publish every of its sources on Docker Hub. So you just need to go to hub.docker.com and try searching Airbyte/source minus anything, and you find the source you want, and you can put it here. So when you run the command, actually what happens, it's going to create a YAML file with pre-generated configuration depending on the source and depending on the destination. So the only thing you need to do is to edit this YAML file exactly as you will do with your DBT YAML file. Then once it's configured, you just have to run it, just calling ABS run, the name of the connection. and it's going to work. It's going to extract the data from the source, send it to the destination. And it's not, yeah. And what's more, just by running this command, it's going to work. It's going to run. It's going to extract the data and load it into the destination. But this is not going to run into your local machine. This is going to work directly in a remote container, which is the remote container that we defined in the serverless, in the configuration at the start. So right now it's going to work on a Cloud Run job, So as you can see, only with a few commands, you could create an extract configuration, run it locally, run it remotely, and then you can schedule it, because on Cloud Run job, you can schedule the Cloud Run job, and we're going to see it later with workflow. And you will have logs, you will have error reporting, and so on. So yeah, in the end, it's like DBT. You've got YAML files, you put this in your Git. So you've got the validation workflows that you want. You can put CI/CD if you want. Yeah, so yeah, to sum up, it's an easy way to deploy self-hosted Airbyte if you want to self-host your Airbyte. Give you the floor, Lynn.
Thank you, Paul. So now I'm going to give some insight. I will be sharing insight into a recent project at Modeo in which we were tasked to perform social media scraping using Apify and integrating the scraped data into BigQuery. The challenge was not only to extract the data efficiently, but also to seamlessly integrate it into BigQuery. And after careful consideration, we opted to choose Airbyte Serverless for the numerous benefits that Paul has just mentioned, and the fact that it's very easy to integrate with an orchestrator like Google Workflows. I will walk you through all of the steps of how we did it. So I'm just going to explain briefly the data platform, the project architecture of this project. So first, our custom source is created. It is built with Docker, and the image is deployed in artifact registry. After that, Airbyte Serverless will access this Docker image, which will do the call to the API or Apify. And after Airbyte Serverless obtains the data from the source, it will load the data into the specified BigQuery project. Once the data is deployed and is loaded into BigQuery, we want to parse and clean the data. And this is where DBT comes in. DBT allows us to perform the transformations that we need to clean the code, parse the data as needed. And we do that, and then we create the tables, the clean tables in BigQuery as well. Once we obtain all of the clean data, then we are able to perform data visualization and create dashboards using Looker. So I will be showing you, I will be going through the various steps of how we deployed Airbyte Serverless in our specific project. The first chunk of steps is to create the custom connector, build the Docker image, and push the image into artifact registry. And for those who are not familiar with artifact registry, just very briefly, it's a collection of repositories which enables you to centrally store artifacts and build dependencies among them in Google Cloud. Ismail, can you let me share my screen, please?
Yeah, sure.
Okay. So here I have a project. It's I had already created a custom source with Airbyte. As you can see, I have the spec.yaml here. I have the source.py, the setup.py, and the configured catalog JSON file. And I deployed the source using the Python CDK, as mentioned before, as explained before. So what I wanted to do at this point was to use the data obtained by this source and load it into our BigQuery project. So I'm going to show you how I built the Docker image and put it into artifact registry, because the goal here is to be able to access the Docker image through the Google Cloud project. So this is how we did it. I have a build source, an sh file here, which will build the Docker image as seen here, and we'll push it into artifact registry. So all I have to do is bash build source.sh. It will take a few seconds. It's done. And now if I go into artifact registry, as you can see here, I have the Appify Instagram post demo that has been pushed. And so after we push that, now the image is accessible by anyone who has access to the Google Cloud project. They can simply pull the Docker image. So now we want to establish the connection. We have created our source, and now the goal is to create the Airbyte serverless connection. So I'm just going to go through the steps that Paul has previously mentioned and show how simple it is. So obviously, before anything, you do pip install Airbyte serverless. I already have it installed, and then you do abs create. And in the source, you specify, for example, here I put the name of the Docker image. The destination is BigQuery, and my remote runner, I want it to be a Cloud Run. So once I do this, this will create a connections folder with the YAML file containing the configurations that we need to modify. So I've already created a connection here. I've already filled it all out, but these are all straightforward. These are, for example, this comes from the spec.yaml. As you can see here, the spec.yaml file that I have, I specified that the required entry for the source to be able to function is a list of post URLs. And that is what the configuration here asks me to fill in. So I have already filled all of that in. I gave it a list of post URLs. I specified the BigQuery dataset and the project name, the region, and the service account for this case. And now what I have to do is, Airbyte serverless. And now if I want to run this connection, so this connection is already established. I've configured everything I needed. That's it. Now all I have to do is run it. I'm going to run it remotely, which will create a Cloud Run job directly. If I click here, as you can see, it created the job and it executed it instantly with just one command line. And now I just have to wait for it to finish. While we're waiting, I'd like to explain the transformation that we do. So the goal here, after we establish this connection, so this job, what it's going to do, it's going to obtain the data from the source, and it's going to put the data into BigQuery. However, the data that's going to be found in BigQuery, in our BigQuery table destination, it's not going to be as exactly as we need it. It's not going to be fully parsed or fully clean. So that's where DBT comes in, and that's why we created a DBT job as well, which will perform the transformations on the extracted data. So this is our DBT project. We configured it as well, and we deployed it into Google Cloud. And these are the queries which allow us to parse the data. Still running. Okay, it's finished. So as I mentioned, we have a Google Cloud job that does the extraction and loading. And then we have the second DBT job, which performs the transformation. So our goal here was to automate and streamline this entire process. And this is where Google Workflows came in. So with Google Workflows, we were able to create a workflow which runs the extraction and load job first. And after this is done, we perform the transformation automatically. So This is an example of the Google workflows which we created. And this is to show you how simple Airbyte Serverless is to implement with Google workflows and orchestration and for scheduling the job. So as you can see briefly here, I'm going to explain this first job. It's going to run the Airbyte Serverless job that has just been created. And this is going to run the DBT job, which we had previously created as well. And now all I have to do is trigger this. I'm going to execute this workflow, and I'm going to show you how it's going to run the extraction, load the data in BigQuery, and then transform it and create new tables with the transformed data. So once I execute this, it will take a few minutes to run, but as you can see here, the same logic as I just explained is implemented. So the init is where we specify any needed variables. This is the Airbyte job, which will do the extraction and the loading. And this is where we do the transformation. So I'm going to check in Google Cloud. As you can see, it triggered the first job. So now it's running again. So Google Workflow successfully triggered the Airbyte serverless job. Yeah, and once this is done, it will trigger the second DBT job. And also, at the end, after we perform all of the needed transformations and we clean our data as needed, we create several tables as well with DBT. This is possible. You can create your dimension tables, your fact tables, your final tables with the KPIs. You can easily create dashboards, as mentioned before, with Looker, which is also a Google tool, which can be easily connected to Google BigQuery to create platforms. So this job is done. We can now, I think the DBT job has been triggered. So we can, while we're waiting for the DBT job, we can check here. As you can see here, I put this data set Airbyte input. So I'm going to check in Airbyte input if it correctly created the table. And as you can see, it did. So this means that all I did was trigger the job through the command line and optionally orchestrate it with Google Workflows. And it did the scraping exactly as needed. I can show you here. This is the data obtained by Airbyte, or Airbyte Serverless in this case. As you can see, there's the job ID, the date, the time of the ID, and finally, this is the data that has been scraped by Airbyte. And this is what I was talking about. This is why we needed to perform the transformations, because as you can see, the data that's obtained, it's all a JSON object. And we needed to create tables from this JSON object. I'm gonna check if the job is finished. Okay, it's finished as well. So this normally, to verify, okay, raw Instagram post. Okay, I can check in BigQuery if in Airbyte DBT raw, there it is. So it created the new table that is fully parsed. I'm going to just query to a very simple query. And as you can see, the table has been successfully created, and you can easily see that because the schema is correct. And you have the parsed data, which also you can do some transformations later on it as well if you need. But this is a very simple and basic way to transform your data with DBT. And that's pretty much it. So now you know how to build the Docker image, push it to artifact registry, and then use this image to deploy it in Airbyte serverless, create a connection with this custom source that you used, run this connection. You can run it in the cloud or locally on your machine, and orchestrate the entire process with Google Workflows, including the transformation step. I'm going, Ismail, if you would like, you can
Yeah, yeah. Well,
to
thank you.
your screen now.
Sure. Thank you, Aline, for your great presentation.
Thank you.
And I think we can move now to the questions.
I
So
see.
thank you. So if anyone has questions, you can ask it in the chats, and it will be a pleasure for Lynn, Paul, and I to try to answer your questions. Oh, we have a question from Paul. From Theo. Theo asks a question: why did you choose workflows over Cloud Composer to orchestrate the pipeline? Someone wants to answer, Lynn or Paul?
Yes, I mean, in this case, very specifically because Google Workflows, I mean, it was very easy to connect our Cloud Run job to our cloud project, and we just wanted to have an entire Google Cloud project with all the dependencies in the Google Cloud project. Maybe it would have been also a really good choice to use Airflow, but in this case, it was very simple to just deploy the Cloud Run jobs directly because they're all in the same project.
Yeah, I can add something again. So what we wanted to build is a serverless data platform. As we know, Cloud Composer is not serverless. It's hosted. It's Airflow hosted in GCP and in a Kubernetes cluster. Even if it's managed by Google, it's costly, way costly than deploying a workflow on demand, triggering a workflow on demand on GCP. So it's mostly because it's we wanted to have a fully serverless pipeline. Yes, Matthew, we always hiring at Modeo. So are there any questions? Anything else? Something not clear?
So Matthew is asking if he can configure the connection in the Python code instead of the CLI. And yes, that is possible. You can import the Airbyte Serverless package and run a remote run directly by creating an instance of a class called connection from file. I think, Paul, you can correct me.
Yeah, exactly this. You can run it from Python directly without using the CLI. Yeah.
Yes.
It should be documented soon in the README of the project, which is not yet.
Yeah, this is a good thing around the Airbyte Serverless, because sometimes we need to do some complicated logic, and having a Python code is a good stuff. So yeah, it's possible.
Yes.
We have another question. Maybe Paul, you can answer this. The sacrificed features when compared to the full Airbyte instance, are they compensated with another layer like the transformation layer?
Yeah. So to answer this, the main features that you will miss is the transformation, because as you saw when Lynn showed it, it will append rows in the destination table in a row format, and what does Airbyte actually? But Airbyte then got a second step of transform, where it can normalize the data to parse it, normalize it, and then run DBT. So now you will have to do it by yourself. On the other hand, the advantage of these missing features is that the Python package is really lightweight. So you won't never have any problem with schema change. The package is stupid. It only moves data and append it to the destination. So if there's a schema change, it won't affect it.
Nice.
And yeah, maybe a second, to be fair, a second thing that you won't have any UI. So if you want to give the tool to some business people, it would be easier for them to use a UI than to configure some YAML files. I guess data analysts now are used to YAML files, that they are more or less most of them using DBT, but still, if you need to have a UI, it will miss. And how much does it cost to run Airbyte Serverless in GCP? Well, it's kind of free. It depends on how much compute, how much time you need, but there are some free tiers on GCP, and it will cost you almost nothing if you have only some few connections.
We don't have any new questions. We still have 7 minutes. So, maybe another question for Matthew again.
Maybe I can answer this one.
Yeah.
As well. Yeah. We don't use database, but actually there are some stuff which are stored. All the logs of Airbyte Serverless are going to be stored at the destination. So there is going to be a table at the destination where you will have all the logs. So what's nice is that you can easily create a dashboard on top of your logs and see how everything went. What's more, Google Cloud Run jobs come with an interface. Lynn showed it. And so it comes with all the logging, the usual logging that you have on Google Cloud. And it comes as well with the error reporting. So when there's going to be an error, you will be alerted, and you can configure some alerts to send to your Slack or so on.
Plus, I think you can also benefit from all the GCP monitoring tools.
Yeah.
So I think it's not easy to monitor serverless, but probably you can do it. Another question: Is the transformation layer in the regular Airbyte more efficient than doing it manually in DBT? Do you want maybe Paul?
Yeah, it's actually what does DBT? It's going to run some BigQuery queries. So in the end, whatever you do it in DBT or you do it, the first normalization step with the code of Airbyte should be the same. If your DBT code is efficient, it will be the same.
Okay, nice. I don't think we have any other question. So thank you. I think. Oh, last question for Matthew. I think. And I can answer this question actually. I don't want. Okay, so thank you, Paul, for your great presentation. Thank you, Lynn, for your excellent presentation, and thank you everyone to assist this webinar with us. And I hope it's the first one of a long series of webinars. And don't hesitate to add comments, to send us some messages to let us know how you found it. Oh, we have a question. I just how is it different from data flow?
You want to answer this one, Ismail?
How is it different from data flow? I think the fact that it's open source and it's just doing the EL part of the ELT process is a game changer, since you can you can use it like elsewhere than GCP. You can have some destination in maybe AWS, Snowflake, and you can even create some new runners, except not only Google Cloud Run jobs. You can have Lambdas and stuff like that. Okay, and so the last thing, maybe I can share. Can you see my slide, the last slide?
No. Yes.
Okay, nice. So don't hesitate to go to visit the repo, the GitHub Airbyte Serverless repo, to put some stars and to